Well, so today we're going to discuss about the other two high availability concepts. Those are clustering and always on. Let us first discuss about a clustering. What a clustering mean? So clustering is nothing but the combination of two or more standalone servers. Can you hear me? All right. So till now, whatever we have discussed, the high availabilities like mirroring, log shipping, replication, those are either at database level or at table level. But what if I need to have high availability at instance level? I have a SQL server, the standalone SQL server, okay, and I have one instance on that with around 10 databases. So if something goes wrong with the hardware of the database, maybe if my OS get crash or if the fan on the CPU goes wrong, so what happens to entire SQL instance on that server? So to overcome this, we can implement clustering. In clustering, what happens is we can add the other server. We need to first create an identical server on the other side with the same specifications like OS, RAM and everything, and we can integrate that server into clustering. And again, building up the cluster is, a Windows team or the system team in your organization, they does this. They build and configure the Windows failover cluster. And again, Windows failover cluster is nothing but the combination of two or more standalone servers. So once they build and configure the Windows failover cluster, we install SQL on them. I will explain in detail about the configurations and what are the benefits we're going to get using a clustering. But the first thing we need to understand is the clustering will give high availability at instance level. Okay, and that is also at services level. It's not at database level. If your database is corrupted, then you will not get benefit with the help of clustering. Clustering will only give high availability at instance level with very specific to the hardware or software issues. If your OS is crashed, still you can fail over your complete SQL instance to the other node on the server. When I say node, it's nothing but a server. And if your primary server has got some hardware issues, then also you can fail over your complete SQL instance onto your other server, which is part of clustering. So basically we need to understand cluster provides high availability at instance level, specifically to the hardware and services, that's the software, but not at database level. If your database is corrupted, even though you fail over your SQL instance, still your database will be in corrupted state. So let me show you the architecture so that you will get an idea. So this is my primary server, and let me get other server here. This is my, in clustering we call servers as nodes. Okay, this is my node 1, node, box, server. All these three mean same. You can either call node, you can either call server, or you can either call box. Both related to same. So this is my node 1, okay, and I get another node, and the node is 2. Okay, these are the two servers, and as of now this is my primary server and have my databases sitting on this instance. So I have a SQL instance with 3 databases running on this node 1. So if something goes wrong with my node 1, so what happens? If I ask you to set up a high availability, Either you select mirroring, lock shipping, or replication, whatever you think you will do on database level, right? So if something goes wrong with your database, it will be failed over onto the other side. But if my hardware goes wrong, if the CPU on the server goes wrong, or if the OS get crash on this instance, how you want to make your SQL instance to get failed over onto the other side, the complete SQL instance. It doesn't matter how many SQL databases on it. So to overcome this, we need to have a Windows failover cluster. So to set up a Windows failover cluster, we would need this identical standalone server, the other one. Then the Windows team, what they does is they integrate these two servers with one name. Okay, so this is a node 1 and this is a node 2, and when they integrate a cluster, that means it will be called with a single name. That's a cluster name. Cluster name, or we call it as a virtual name. So clustering is nothing but combining two or more standalone servers. I have just picked up two servers for an example, but in real time you might have 3-node cluster, 4-node cluster as well. So when I integrated these two nodes into a cluster with a virtual name, then what happens is every time if you want to RDP, generally if you want to RDP onto a server, when I say RDP, it's a remote desktop. If you want to log in onto that specific server, what we do is at this moment we provide the node 1 name or either node 2 name. Okay, but if you can use a Windows failover cluster name, the virtual name, if you use this virtual name, it automatically takes to the node which is active. So in cluster we have two types: active cluster, active passive cluster. Active cluster is something where the two nodes will be active and responsible to run two different instances. Node 1 is running one instance and node 2 is running second instance. And active passive is something like the setup which you are looking now. The node 1 is running your SQL instance at the moment. During that time, your node 2 will be idle. Your node 2 will be idle. Still the server will be up and running, but it just sit idle and it's keep on monitoring your node 1. So your node 2 will keeps on monitoring your node 1, and the same way your node 1 will keep on monitoring your node 2. So this mechanism we call it as heartbeat. So there will be a heartbeat between these two nodes. So what it does is for every 60 seconds node 2 will ping node 1, and for every 60 seconds node 1 will try to ping node 2. It's just something like node 2 will go and check whether node 1 is up and running. If it is up and running, then node 2 will be idle. If node when node 2 issues a ping request to node 1, and if node 1 is not responding, unfortunately, then node 2 will make a decision that, oh, node 1 is down, it's not responding, so something wrong with the node 1. So it is the time now I have to take a responsibility and run the SQL instance on my server. So that way the complete SQL instance will be failed over onto this node. and this node will become active and the node 1 will become passive. So at any point of time, one node will be always passive, that is idle. It will just wait for an responsibility to take over. So in this, we have a common storage. Danish, what you want me to repeat again? Is it any specific? Okay, all right, the failure part. Sure, I will do that. So uh, the setup will be quite different here. The storage, if you look at the storage on your laptops, the drives, either the C, D, E, or whatever it may be, it's a physically attached, right? But in real time, in real servers, the drives will not be physically attached to the servers. So the drives will be either a NAS or SAN, storage area network or network area storage. So it will be in a network and the storage will be pointed to a server, but nowhere the drives will be physically attached to servers. It doesn't happen in virtual and real servers. So coming to the SQL clustering here, we have a SAN. It's a network, it's a storage area network, and assume this server is active now. The node 1 is active. So when you install, probably I will start from beginning, like okay, treat this as active and this node as passive. That means always this node will be taking the responsibility of running your SQL instance, and your node 2 will just be idle and wait for a failure. So now when I install a SQL Server, what we do is first we jump onto this SQL instance, that is a node 1 server, and we run the setup file. And when you run the setup file, you will be provided with an option at installation. So let me show you. Okay, if you go on to left side installation, you can see the second option, new SQL Server failover cluster installation. So if you are installing the SQL Server on a cluster environment, you need to select this option. So using that option, we install the SQL on the first node. So before we install, we need to keep certain things ready. So what are those? It is, one is the SQL virtual name. We required a virtual name of the SQL. I will explain you why it's required. And then after, we need to have the associated IP address and the service account. We already know we require a service account, and then after the shared drives. So the shared drives will be in your storage area network. So once you are ready with these things, we kickstart the installation, and once we are done with installation on node 1, we jump onto the node 2, and there you run the setup file again, and now you select the third option on the second node. It's nothing but add node to a SQL failover cluster. So you already installed a SQL, complete SQL here. So you RDP onto this server and you just select add this node to this failover cluster. So you don't need to provide more details. It will just ask you one or two inputs and it will finish off the installation. So ultimately what we have done is we have installed SQL on node 1 and on node 2. So the SQL services will be available on node 1 and as well as on node 2. Along with the SQL services, as this is a cluster, you also find a cluster service installed on node 1 and on node 2. One more thing we need to remember is the logon type. If you go back to your SQL configuration manager, the logon type for SQL services, either it might be manual or automatic. So you can see the startup mode either is automatic or manual. For standalone servers, you can select automatic. Okay, that means whenever your server reboots, your SQL services automatically try to come online. But in cluster, those services should be manual. The SQL services should be set to manual. It is because the cluster service, whatever is available on these two nodes, those cluster services will be responsible to bring your SQL services online. So you don't need to make it automatic, or you don't need to manually go and start the SQL services. Whenever a failure happens, the cluster service will bring those SQL services online. So that's the responsibility of the cluster service. So please do remember, the SQL services should be kept manual in cluster environment. And the reason we need to understand is because the cluster service will bring the SQL services online. So the other thing is, once you are done with the SQL installation, having said that, we need to provide the shared drives, right? So you provide the shared drives information. Probably when you RDP onto the server and you go to my computer, you will find all the drives. Apart from C will be physically attached to that server. So you can also find MST. Let me make a note here. So I have, again, this is a work of your storage team. They will assign the drives onto your server. Probably you can find M drive, L drive, S drive, and T drive, and you also have a C drive which is very local to your server. So the MLST or shared drives, and C is your local drive to this node. And these particular drives, you can see once you log in on the node 1, you can see all these drives exist. So you can't distinguish whether these are shared drives or locally attached to the drive. So that what the it looks like. But ultimately those are pointed to a SAN. They are not physically attached to this server. So now when you create your databases on this instance, you have installed your SQL Server. Now you try to start creating your databases. So you have to create your databases on these drives, MLST. Okay, you can't create the drives on C drive. You have to create on shared drives. Why you have to create on shared drives? It is because when a failover happens, okay, when a failover happens, the link between the storage, the link between the node 1 and the SAN will be disconnected, and the same link will be established to your node 2. The link to the storage will be established with the node 2 because a failover has happened. Now node 2 is active, so the link from node to the storage will establish, and all the drives that were earlier present in node 1 will be available on your node 2. So your drives, the MLST drives, will come over here. However, you have a C drive locally to the server. So the entire drives will, these 4 drives will get failed over onto the other side. So once a failover has happened, okay, now if you log in onto node 1, you only see C drive. The remaining MLST drives will not appear. It is because this node 1 is now passive. It got failed over, right? So this node 1 is now passive. So as soon as it went into passive, the connection to the storage got disconnected, and the node 2 is now active. That means the connection got established with the SAN, and all the MLST drives will be failed over onto this node, and your cluster service, which is running on this instance, will bring your SQL services online, and we have got all our databases on these drives, so your SQL databases and instance will come online and it work. From user perspective, in database mirroring or log shipping or replication, take an example of database mirroring. So we'll have a principal server and mirror server. So take an example that your databases are currently running in principal server. So users are connecting to your principal server. Now something went wrong and your database got failed over onto the mirrored server. Okay, so your mirrored server has become now principal and your principal server has now become mirror. So when users, all their upcoming connections still be pointing to your old principal, which is now a mirror, will get failed because the database will be in restoring mode. It doesn't allow any connections to it. Now we have to inform that application team saying that, oh, the database got failed over onto the mirror node. Now change your connection string pointing to that new mirror server, that is a new principal server. So they have to change the connection string all the time when a failover happens. It's the same thing either in mirroring, log shipping. But in clustering, it's not required. So that is what the use of SQL virtual name. So SQL virtual name is something given on top of this one. So here they will be giving a, we will be giving a SQL virtual name while we install a SQL server. So we give a SQL virtual name while installing the SQL server, and we provide this SQL virtual name to all the end users and application teams. We don't give the name of node 1 or name of node 2. We always give SQL virtual name, that is a SQL instance name. So whenever a failover happens, it doesn't matter for them. So as they are using a SQL virtual name in their connection string, it comes to here and your cluster will ensure to divert its connection to the node whichever is active. If my node is active at the moment, so all the connections will come to the node 1. And if my node 2 is active, then all the connections will automatically divert to node 2. So from user perspective, he is not aware whether the SQL instance is running on node 1 or on node 2. He still thinks that, okay, this is the SQL instance, this is a server. He don't even know that it's a cluster or a standalone until we go and tell him. So the benefits of this clustering is, having said that, the hardware issue or the software issue with the node 1, you can fail over the SQL instance onto the node 2. And still the users, they don't need to change any connection strings, and probably the failover will only take seconds. The maximum of 3 seconds, that's the maximum. So imagine if you have 100 database on the instance, those 100 database will quickly fail over within a second onto your server, the second node. So we are talking about a heartbeat here. So we need to go into in-depth about this heartbeat. Having said that, for every 60 seconds, your node 2 will try to ping your node 1. And if it gets a response, if it gets a successful response, then your node 2 will acknowledge that, okay, node 1 is up and running and it is taking care of your SQL, so nothing to do. And the same thing, your node 1 will ping your node 2 and check whether my partner node is up and running. If something goes wrong with me, is my partner node available immediately? So it gonna check, both will check the other side whether the other person is ready to take a responsibility. So that happens every 60 seconds. But still, that doesn't give you exact fault tolerance, because the chances are when you issue a ping request from node 2 onto node 1, probably you might get a successful ping request back. The server might be up and running, but there could be something wrong with your SQL in SQL software, or your SQL is not responding, or your SQL server services are stopped. So what next? Probably the server is up and running, so you get the ping request. But inside the server, your SQL services are not running, or eh, there's something wrong with your other softwares that is hanging up your SQL, and your users are facing issues to connect your SQL instance. So to overcome this, inside this heartbeat, there is one other mechanism which is a looks alive. Sorry, I just jumbled it. The first thing which runs for the one which I said ping request, right? That is called looks alive, and it runs for every 5 seconds. So let me make a note here. Looks alive, what it does is it does ping every 5 seconds. Okay, every 5 seconds it does a ping to each other. And having said that, ping request might get succeeded, but internally SQL might not be responding properly. So that time there's a one more mechanism which internally works is alive. And what this is alive does is from node 2 it goes to the node 1, connects to the SQL instance, and issue a command called select @ server name. Just a basic command to ensure whether your SQL is responding or not, or whether your SQL is allowing a connection or not. So to further confirm it is alive, it runs for every 60 seconds and it issues a command called select @ server name. If it gets a response from your node 1, then everything is all right. If your ping request gets succeeded but your the is alive select @ server name is getting failed, for the first time it will try to issue again after 5 seconds. So it waits for 3 failures. So if it thinks, okay, all the 3 times the select @ server name, the SQL is not responding on the other side. So that time your SQL will make a decision that to initiate a failover. The node 1 SQL instance is not responding for the continuously 3 times, so a failover should happen now. So once a failover is initiated, the complete SQL instance will come onto this side and the associated drives will also move onto your node 2. And again, it won't take maximum 3 seconds. It will just swap the roles on the other side. It might take max of a second or 2 seconds. And the other advantage is in our, probably it's not a day-to-day activity, but probably every quarter, we have to update or apply service packs or security patches on our servers. So if it is a standalone server, how do you apply service pack? So we just right click and start our service pack and we apply on it. And the service pack wizards and the installation might take you around 30 minutes. Let's assume the service pack installation might take you 30 minutes of time. So that 30 minutes will be a downtime for your business, because when it applies service pack, SQL services will be brought down and service pack will be applied, and at the end the services will be brought back again. So during all that service pack installation time, your SQL services will be down. That means your business will be down. So to overcome this, we can use this SQL clustering. So what we can do is, in this case, my node 1 is active and node 2 is passive, right? So nothing is running on my node 2. So in this case, what I do is to have a minimum downtime. My business doesn't accept me 30 minutes of downtime to apply service pack. Okay? It's because it's a very critical database application. So in that case, what I do is I first apply the service pack on my node 2, then I reboot this node 2, it doesn't affect, even though I reboot this node 2, it doesn't affect to my end users because SQL is running over here. So all the transactions, all the connections that are coming to this cluster will be diverted to this instance. So it doesn't make sense. I mean, it doesn't matter even if you reboot the server. So once I apply the service pack and reboot the server, and when the server comes back online and joins this cluster, I go back to my node 1 and I manually failover the SQL instance onto node 2. We will have a failover cluster manager console from where we can failover the SQL services. I can't show it now because I don't have a virtual servers with a Windows failover cluster, but you once we finish with this training, you can browse the YouTube videos where quite few people might be showing you with the cluster installation. So once we failover the complete SQL instance on node 2, then your node 2 will become active and your node 1 will become passive. So at this point, all the new connections will be forwarded to your node 2. Okay. So now your node 1 is active. So you have to apply the service pack on node 1 and reboot it. And once the server comes back online, you go back to your node 2 and fail back the SQL services on node 1. So we are trying to fail over 2 times with a max of 2 seconds. So just imagine if you have only a standalone server, you are taking 30 minutes downtime. And in cluster, we brought it to 2 seconds, from 30 minutes to 2 seconds. So that's the benefit of a cluster. So is it clear? Probably it might give you some confusion, but having said that, once you're done with this training session, probably I suggest you to go back and browse some videos. Yeah, Venkat, that's what I'm saying, how to fail the cluster. We will have a failure cluster console. I can't show it here because I don't have a setup of that. We will have a failure cluster console where we'll be provided. We just need to select the SQL services over there, and just we need to right click and select failover. That's what we usually do, but it really makes sense if you look at that one. So that's the reason I'm suggesting to you to browse the videos. So this is the basic logic how a clustering works. So in your interview, if you can explain the basic things like what a cluster is and how it really works, and if you can take a points like looks alive, is alive, the SAN, the shade, how the drives will get failover. If you can explain this one, that would be more than enough. So any questions regarding this clustering? All right. This is a question from Kaushik. When we start applying service pack on node 2 and reboot it, it takes some time. But if node 1 sends messages to node 2 and it doesn't respond, does node 1 think node 2 is failed? Yes, obviously. But node 1 will sit there only because it doesn't fail over. Already your node 2 is down. Let's assume to reboot your node, it might take around probably 3 minutes of time in order to get a reboot. So during the 3 minutes of time, your node 1 will try to ping your node 2 and it will get a response that, okay, your node 1 is down. So all these things will be recorded in cluster events. It will make a note in a cluster event saying that, warning, your node 2 is not available in a cluster. If this is clear, we jump on to the always on topic. Shall we go ahead with the always on now? All right. Always on is an enhancement of database mirroring. If you really understand what a database mirroring, then it is very easy to understand always on. The enhancements of mirroring is called as a always on. I think I already raised this point that starting from 2016, you don't find database mirroring. The database mirroring has been the database mirroring will be removed starting from 2016. In place of database mirroring, Microsoft has introduced always on from 2012. So if you remember the good things like the benefits from database mirroring, that is, we have automatic failover, right? In database mirroring, we have automatic failover, and the data will be transferred through endpoints 5022 and 5023, and with the help of a log cache, right? These are the benefits, or we can say good points from database mirroring. And now go on to log shipping. What are the advantages of log shipping? Can someone tell me what are the advantages of log shipping? What did you notice, I mean, a difference in log shipping when compared to database mirroring? That's right, Venkat. We can maintain more than 2 copies. And we have one more good advantage in log shipping. In mirroring, what is the state of your mirrored database? In mirroring, your mirror database will be in restoring mode. That means it will not allow you to read the data, or it will not allow you to make a connection to the database. But in log shipping, your databases are in standby mode. That means you can read the data from your secondary databases. So the good points from log shipping is multiple secondaries and readable secondaries. You can read the data from secondaries. So the two advantages from mirroring and the two advantages of log shipping, the combination of those four, I mean the 2 and 2, is implemented in always on. So in always on, the benefits you're gonna get is you can have multiple secondaries, and those secondaries can be readable, and you can have automatic failover. So all those four are integrated in always on. And the other benefit is you can group databases. So let me make a picture over here. And I can say it does have a feature from a clustering as well. So always on is a combination of mirroring, log shipping, and clustering. All the advantages from these three were picked up and added to always on. So I will make a note here. One is multiple secondaries and secondaries in readable, and third is automatic failover. This automatic failover with the help of cluster feature. But the clustering which we talked just before is slightly different the clustering we will be talking now. There's a slight difference. Just before, the clustering which I said is a complete Windows failover cluster. But in always on, we just need a feature to be enabled. A cluster feature need to be enabled. We don't need a complete cluster setup here. We just need to have a Windows failover cluster feature need to be enabled, and we don't need a shared storage. In Windows failover cluster, the one which we just talked about, it got a shared storage, right? That shared storage is not required in always on. Each individual server will have its own storage. So I will pick up 3 nodes that make sense. Okay, so this is my node 1. So I make it inside node 1, and this is node 2, and this is node 3. So I have got 3 nodes here, and in node 1 I have multiple databases. Okay, so I have 4 databases, and these 4 databases are related to one application. Assume these 4 databases are required to run one single application. If any of these 4 databases, let's say first database is down for some reason, then even though your remaining 3 databases are online, but still your application will not work. That is what the configuration we have. In SharePoint, the same configuration will have. SharePoint application does contain multiple databases. If one of the databases is down, your application won't work. Okay, so it's nothing but one application, multiple databases, the dependency. So in this case, if you set up database mirroring or log shipping or any other things, you have to set up individually on each and every database. And if your one database will fail over on the other side, okay, your 3 databases will be running here and one database will be running on your second node. During that time, your application will not work. It's because it is missing one database on this instance. How it works is either fail over all the databases onto node 2 or don't fail over anything. That's the case how application works. So in that case, we can't rely on database mirroring or log shipping. It doesn't work. So we need to have a different mechanism that Microsoft came up with always on. We can group all these 4 databases. We can group all these 4 databases and we call it with a name called availability group. I'm writing in shortcuts AG. So we group all these 4 interrelated databases into one group and we call it as a availability group. We name it maybe something like you can name it as depends on application. If it is SharePoint application, I name it as SharePoint underscore AG. So I'm doing nothing but just a grouping all the 4 databases so that I'm asking my SQL Server to treat it as a group. If any single database has any issue in this group, fail over complete group on the instance. Assume my the database 4 has got some issues and it went offline. That time, fail over the complete group onto the other side. That's the mechanism of availability group. So that's what we required, right, in order to run the application. Either fail over all the database on the other side or don't fail over anything. That's the mechanism. Can be done with the help of availability group. So all these 3 nodes will be in cluster. So there will be a link between all these 3 nodes. Okay, they will be in cluster. Now I'm giving some very advanced configuration here. Assume my node 1 is in US. and node 2 I still keep it in US, and node 3 I keep it in Europe. It's because the first two nodes I keep in same data center to get high availability. If my node 1 goes down, automatically all the availability group databases, whatever it may be inside the group, how many it may be, will be failed over onto node 2. Okay, that's an high availability. And the third node, I'm keeping this third node in a different geographical location in order to meet a disaster recovery. When I say disaster recovery, that means you can see the first two nodes are located in same data center. Okay, so if there is an issue with the hardware of first node, the databases will fail over onto node 2. But if there is an issue with the complete data center, assume there's a power outage to a data center or the water flooded into a data center, then these two nodes will be down. Then you will have a third node which is sitting in Europe, will pick up the databases and it will work. So that's the main intention to have always on. So as we have got a cluster, right? It's only a fellow cluster. It's not, it doesn't have any virtual name or something. Still, each individual server, each individual node will have its own SQL instance name. Probably this has a SQL instance name called SQL1, and this has got SQL2, and this has got SQL3. Now my question is, probably you might get the same doubt. If when I say the entire group will get failover onto node 2, and assume the availability group is now running on node 2, okay? At this moment, the users or the application team, they have to change their connection strings. That the one thing we need to understand. Earlier, when the availability group is running here, they use SQL1 as their connection string and they will connect to this instance. And unfortunately, a failover has happened and the SQL databases got failover onto this server. Then still users are trying to connect using SQL1 and they will get a failure that the SQL services are not running due to some reason. So someone from a DBA team has to tell them that, oh, the SQL1 is down for the moment, you try to connect to SQL2. Or if SQL2 is down, then we need to tell them to connect to SQL3. That's a bad practice. If a failure happens at midnight, we will not be available to the users to shoot out an email saying that, oh, SQL1 is down, connect to SQL2. That's what we'll be doing in mirroring and log shipping. We don't want to do that. We don't want to do that in always on. So in mirroring and log shipping, we does the same thing. If failover happens, we go back and inform these users saying that, okay, the database got failed over onto the node. So try to connect to that server. But as we are saying, this is a new technology or new feature introduced by Microsoft, so we don't want to repeat that steps. So to overcome that, Microsoft came up with a option called listener name, AG listener name. I just write it here, AG listener name. You need to place a request with your Windows team asking, I need a virtual name with an IP address. So you can use that name as your AG listener name. So when you install your SQL Server, you normally install your standalone boxes. How you install your SQL services, SQL Server on your local machines. The same way we need to install on all these three nodes. There is no specific conditions you have to follow. It's very common how you normally do on your standalone boxes. The same thing we have to do on these three nodes. Once you are done, and if you are asked to set up a always on, then you need to go back to your SQL configuration manager and go to the properties of SQL Server, and inside the properties here on top you can see always on high availability. You can click on it, and as my machine is not part of a cluster, so it's not giving an option. But if my machine is part of a cluster, then it will give you a checkbox over here saying that do you want to add this SQL to a always on. So you need to check that first before you start setting up always on. That's a very important point. When you are asked in interview, how do you configure always on? Then the first thing what you have to tell you is the node should be in cluster. Then after you have to enable the failover feature in configuration manager on service properties, and then you try to take a full and log backup of this database and restore onto SQL 2 server and SQL 3 server with no recovery. I repeat, with no recovery. As we have done in database mirroring, the same way we have to take a full and long backup of the database on node 1 and restore on node 2 and node 3 with no recovery. And then we set up always on. You need to go to your SQL instance. Probably I need to start. Okay. So once you connect to a SQL instance, you can see always on high availability. You need to expand this always on high availability. It doesn't work for me because always on feature must be enabled. Having just shown you just before, we need to enable the always on feature on SQL service properties. So once you enable that, then only it will give you the underlying options here. So I will try to find out a YouTube video, a good YouTube video, and I will try to share it with you. But in the meantime, uh, please search at your side how to configure always on, because I can't show you and I can't make you imagine how a wizard looks like. So the advantages I'm gonna definitely explain you. So the advantages are something like the overall architecture, it's works same how we discussed in database mirroring. The application team, if they do any changes onto your database, the log cache, the log block will be completely be pushed onto your node 2 and node 3, and then it will apply on node 1. And the other thing is the availability modes, which we discussed in database mirroring: synchronous commit and asynchronous commit. So in this type of setup, when you have three nodes and first two nodes in same data center and third node in different data center. So in this setup, between these two nodes which are in same data center, the data access or the data transfer will be fast, right? These two servers I have just kept adjacent to each other in same data center. So the data will transfer very quick because they are in same data center, they are same in network. So I can set it up as a synchronous commit. I can set it up synchronous commit between node 1 and node 2. So when you set up synchronous commit, you will be provided an option for automatic failover. So I have got automatic failover between node 1 and node 2 by setting a synchronous commit. So when a failover happens on node 1 at any midnight or any weekend or any holiday, your SQL itself take care of it. It will fail over the database group onto your node 2 because we have set it up automatic failover with synchronous commit. And it works the same way. When we set up synchronous commit, the data will be first pushed onto your node 2 and your node 2 will commit the transactions and it will send an acknowledgement back to node 1 saying that I am done. Then only your node 1 will commit and send back results to the user. So that's what happens from node 1 to node 2. But coming to node 3 now. As my node 3 is located in a different geographical location, I can't make it as a synchronous commit. It is because if I make it as a synchronous commit, then what all the transactions that are coming onto this instance, this node 1 has to send a log block to this node 3, as it is located in a different geographical location, it gonna take a long time, and the node 3 will execute it, and it has to send an acknowledgement back to node 1, and again it will take a long time. So that entire time user has to wait and look at the results. So we don't want to get a huge latency. So that's the reason we always try to keep synchronous commit between the two nodes that are very close to each other, and the third node, which is a bit far, we configure it with asynchronous commit. So when I say asynchronous commit, there is no point of automatic failover. So the automatic failover is only possible from node 1 to node 2 and node 2 to node 1. But automatic failover will not occur on node 3 because node 3 is set as asynchronous commit. And in this example, if my node 1 and node 2 both goes down, you have to manually fail over the database on node 3. Yes, obviously that's the meaning of a DR. Disaster recovery is something where you have to accept data loss. And the other benefit with the always on is the backups. You can take backups on node 2 and node 3. At the moment, my node 1 is primary and node 2 is secondary and node 3 is secondary. Okay, so node 1 is primary. That means all the transactions, user transactions, are hit by node 1. So already my node 1 is under pressure, and if you try to take backups on node 1, then there will be more load on your primary server, that is node 1. So using this always on, the other benefit is we can divert our backups on node 2 and node 3. It is not mandatory that you need to take backups on node 1. You can take backups on node 2. So by that, we are removing some load from node 1. So it's still possible. You need to remember that point as well. Backups can be possible on node 2. And however, your database on node 2 and node 3 are readable, so you can ask all your reporting users to connect on node 2 and node 3 to generate the reports instead of everyone hitting on node 1. So these are the benefits with the help by configuring the always on. But probably you will get more idea once you look at the configurations. But the overall architecture, how it works, is the same, which I explained it now. So if you are able to understand the logic, how it works, and why the always on is being used, and what are the benefits we're gonna get, that would be more than enough. So did it make sense? Did you understand anything about always on? For the interview purpose, basically you need to be in a position to explain it the same way which I'm showing here. You can start explaining to interviewer, saying that okay, assume that I have got 3 nodes and first 2 nodes are sitting in US and third node is in Europe. Then after you can get an immediate question from the interviewer saying that okay, why the third node in Europe? Then you can explain it that the third node is for disaster recovery. Then you can explain the configuration like, okay, the first 2 nodes in US I set it up as a synchronous commit with automatic failover, and the third node in Europe I set it up with asynchronous commit with manual failover. And the benefits of the always on is the secondary replicas will be readable. So I ask all my reporting users to connect to the secondary databases and generate the reports, and I can even take backups on my node 2 and node 3 instead of node 1. And again, it's an automatic failover I have got here. And the other benefit is you can failover a group of databases at once. And the other benefit is a listener name. Users, they don't need to change the connection strings when a failover happens. It doesn't matter for them whether the databases are running on SQL 1 or SQL 2 or SQL 3. It doesn't matter. They always use a listener name. You will provide a listener name to them and they will use all the time. So any questions regarding this? I will try to find out YouTube videos on that. In the meantime, you can search, and if you feel that if you find any good YouTube videos, you can share across to me, and I will cascade that to the remaining people in this group. But one thing I would like to tell you is always on is a new feature, so everyone is looking for that. For interview purpose, if you look at the job description, always on will be a must. So you should be at least in a position to explain what is the benefits and why you go for always on. So that should be good. Yeah, that's it from my side today. And we left with one more class. So tomorrow we're gonna discuss about the performance tuning, how to tune our servers and how to troubleshoot them and what are the areas we need to monitor. So we discuss more about the performance tuning in next class. So if you don't have any questions, I would like to close the call now.